Well, I've been working with C. elegans for over 20 years now, which is a bit of a shock. I started working with them during my internship, during my bachelor's degree. So my undergraduate was in biochemistry in Cardiff. And I worked with a really wonderful PhD student at the time, Jodie, and she was so excited about the worms and everything you could get from all the information you can get. And that project was looking at the impact of pesticides on development and reproduction. And that really just sparked my interest in this fantastic little beastie. And I was lucky enough then to progress onto a PhD using C. elegans again. And there I was looking at heavy metal detoxification. And I was really fortunate that I could work with different collaborators and different institutes and gain loads of different techniques. And from there, I was just like, I was hooked. So, and I've never stopped working with C. elegans and using all the different tools. And I think and then once I finished my bachelor's and my PhD, I went to Oxford for my postdocs. I just continued working with C. elegans, basically. What comes first to my mind? I think maybe just the utility of the worm. So you can use it to answer so many different research questions, both fundamental research as well as applied research. I really think that there are no problems that can't be solved in some degree to using C. elegans. It's so well characterized. We have a fantastic worm community, and all of these things come together for just a really fantastic model system. The one standout moment for me was in my first international worm meeting I went to when it was in UCLA in the States. Martin Chalfie gave a keynote speech, and he'd just been awarded the Nobel Prize. And he had his lab journal up there, and it was like the idea behind, is this GFP from a jellyfish in a worm going to work? It was just mind-blowing. And then after that, I mean, he's my idol, right? I mean, I think he's a fantastic scientist and amazing person. And I got to meet him, and I think that's what's nice about the community. These people are not random scientists who sit in an office somewhere. We meet them and you can interact with them. And I think that's probably the most inspiring. And I think it's still relevant today. Like Gary Rivkin and Victor Ambros got the Nobel Prize last year. I mean, they're still going to worm meetings and engaging with people, and it shows that worms and the work we do are still relevant. Well, according to the European Chemical Agency, a NAM is any method that provides information on the hazard or a risk assessment of a chemical that contributes to refining, reducing, or replacing animal testing. And for me, C. elegans fits perfectly into this box. So I really believe that C. elegans adhere to the 3R principle of replace, reduce, and refine. They're still novel, so I think we can use them. There are bottlenecks, but I think one of the significant advantages is we can use a whole life approach. So we can use the C. elegans from the moment of birth, from when they emerge as an L1 from the embryo until they die, because there's no impact in terms of legislation. At the moment, worms are still considered a non-animal model, so we can still use them. And that's something that you can't do in any other system at the moment. And we're able then to connect the exposures at different vulnerable age groups, age time points, and see how chemicals impact longevity, health, growth, reproduction, neurodegenerative disease onset, and compare this to higher organisms as well. I think there's been a great deal of work done by some fantastic scientists over the years to show that the relevance of C. elegans, at least in terms of toxicity testing, there's alignment with the mammalian responses, and together this just reinforces the translational potential of C. elegans. So from my perspective, C. elegans is a NAM. It really strictly adheres to the 3R principle. So I think, yeah, use it. Well, I think first we should acknowledge that even the percentages of animals used in toxicity testing is quite small in general when you compare to the number of animals we use for food. So that's something we should bear in mind first. But of the animals that we do use, there is a lot of them. And the most commonly used animals are rodents, so mice and rats. And traditional toxicity tests, they use rodents and they look at the adverse outcome of a chemical exposure. So you take your rodent, you expose it to a chemical, and you see what the effect is, reproduction, death, whatever. And the OECD has lots of test guidelines for this, and they stipulate how many animals you should use, of which sex and age. And if you think about a multi-generational development and reproductive tox tests, such as Test Guideline 418, for example, this requires over 2,000 rodents. So not only is this consuming in terms of volume of rodents, it's consuming in terms of time, money, labor, all the setup for doing this. What if it doesn't work? Then you have to repeat it. And that is just that's just ethically a lot to take in and lot of societal impact. So if we could transfer this and do something in C. elegans, we are not just restricted to a 2 generation, we can do many, many more generations. We can do this in a much shorter space of time due to the quick lifespan and quick generation time of the worms. And it's cheaper, it's more efficient, we can get our data much quicker. I'm not saying that worms can be a complete replacement, but we can at least have a tiered approach where you might say, okay, we have 1,000 chemicals, we'll screen them first in worms and then take our hits onto higher organisms. And I think that's where C. elegans can really add value, along with other organisms, right? So it's not just C. elegans as a NAM, but zebrafish, embryos, Drosophila, for example, can all contribute to this. The number of chemicals we have to screen now is growing exponentially, and in some cases are just not tested for certain types of toxicity. So worms are one of many different ways we can work towards understanding toxicity and relate this to humans. The caveat being, we can't replicate all aspects of human biology. But that's not just true to C. elegans, this is true to all different species, including rodents. One of the most utilized tool in the NAMS approach are cell-based assays. And these are fantastic because they are as human relevant as you can get, because you can take cells from humans. However, they do lack functionality because they are one cell system. They don't have the feedback loops that you require from a multi-systems organism. And organoids are another option. But of course, that's hugely time-consuming and very expensive. So we need a platform. We need a whole series of organisms across different scales of organization, biological organization, to really be able to answer the research question. And that's where, at least to me, C. elegans has massive added value. I think if you can combine complementary tools, C. elegans, zebrafish embryos, cell cultures, organoids, you can find the species that works best for your research question and then translate that to other systems and higher organisms and so on. My first thing I have to say is that the people who've been working on C. elegans, and there are a lot of us, we have such a fantastic base in which we have information about development, about aging, about reproduction. We can understand fundamental biological processes, and there are homologs in humans, right? So we've discovered things in worms that we know are true in humans. So worms are applicable. I don't think that's in question. But despite all of this, for some reason, the uptake in toxicology and in ecotoxicology in some respects is also quite lacking. So there is an ISO guideline for environmental toxicology with C. elegans, but there's still no OECD guideline. How to solve this? well. I think, yeah, bringing the actors together. But I think people who work on C. elegans need to connect with other species, so zebrafish embryos, maybe mammalian cells, and test the same compounds. We need to understand what's the strength of our systems, but also the limitations of them, the capabilities. But we also need to understand how chemicals function in the different organisms so we can make valid comparisons. So if we think about toxicokinetics, toxicodynamics, there are going to be differences between worms and humans, but if we can understand that, then we can make better predictions and better models. So the extrapolation from worms to humans is much more solid. To the general public, I think I have to say that worms are awesome. I'm still, after 20 years, I'm still very excited about how you can see so much. So I just moved into Vafnia and I had some worms up on the microscope, and you could see the eggs being fertilized and traveling through the germline. And, it's still fantastic and still amazing. So to the public, I would say, be open to it. To young scientists, I think I would say be open to the opportunities that present themselves to you. Be open to new things and be curious. So go and see what's out there. I did leave the worm community for a while. I went from roundworms to flatworms for a year. I took my knowledge from one system to another, and that was really, really informative and really fun. I went back to roundworms, so it wasn't that much fun, but it was good. It was really nice. And I think without being open to these opportunities, I wouldn't have moved to the Netherlands. So that's really fantastic. And I think to funders and policymakers, I think this roadmap to non-animal methods and this transition to animal-free testing, this is fantastic, and I'm totally open for it. But we cannot just go from animals to organoids or animals to cell-based assays. There has to be a transition. And C. elegans and zebrafish embryos and Drosophila are all part of this transition. And so we have to work with policymakers to understand this, and they have to work with us so that we can help them within this transition. So yeah, organoids are great. They're very sexy, but they're not the answer to everything. So we should embrace other things.